Hi, I'm Pratik, and this is a presentation on Assessment 2 of SIT 718. The objective of this assessment is to perform exploratory data analysis and using insights from that data to build statistical models. We do that by comparing different aggregation methods. The dataset given has 9 variables in it, of which 8 are independent and 1 is dependent. Wherever the data is not mean-centered, that is not distributed normally, we use normalization to squash it in 0-1 range, and wherever the data is distributed normally, we use standardization as our transformation. Then we move on to exploring different aggregation functions. We have used 3 different aggregation functions in this. The first one is weighted averaging mean, the second one is power mean, and the third one is Choquette integrals. Now weighted averaging mean gives different weights to different variables present in the data. Power mean is more generalized form of that, and Choquette integral uses fuzzy measures to build aggregation function. After that, we also dive into approximation. We do that by linear regression model. It is the process of fitting a best fit line through a given data point. Now these points could be multivariables or a single variable. Now whenever we create a linear regression model, the linear component is the weights that are being trained. So say we have n different variables, then the coefficient of these variables would be related linearly with each other. To summarize, we can say that statistical modeling is a really powerful tool when we need to find hidden pattern in a given dataset. We saw how aggregation function work and how power mean was the best performing aggregation function on the given dataset, where p is equals 2 was used to build a model. We also saw how linear regression can be used to build an approximate model, not an aggregate model, but rather approximating on the given data, and which can be used to predict values on an unseen data which are not part of the training data. This method can be really useful when we need to perform predictive analysis. Thank you. That's all.